lobby, which is a multiplayer server for Godot, with which you can make games like this. The benefit of it is that you can run all the code on the server, and you don't need to use nodes or anything. You can just code it directly there. So it separates all the server logic from the client logic. It will just use Godot as a renderer. So let's first look at what is offered here. There is a tiny lobby starter. This is a repo you can go to, and you have all the information needed. Tiny lobby is, of course, open source, so you can download the latest server from releases. You just take the latest release. And then you also have a Godot add-on. It's also open source. You can install it by going here and you look for Tiny Lobby, you click download. After you download it, you will have a node of type lobby client and scripted lobby client. If you look at this README for the starter, you'll see it tells you how to get started. You can either start with Docker or just download the binary and run it. For me, I just download the binary and I put it in the server folder. And then the binary is called Tiny Lobby. And then I just go into this folder and I just run Tiny Lobby. And then it will tell you that it found some folders. And inside the folders, there's Lua files. This is what it uses for the backend. Okay, so let's look at the first sample. The echo one. In this case, on the server, I have a simple echo function, and when I click send, it gives me back the same message. So in this case, on the server side, the folder is called echo. So if you look at the implementation in Godot, I have a scripted lobby client because I want to run code on the backend, and the game ID has to match. It's echo. And then all I'm doing is returning a message back. And then looking at the code, I'm exposing the lobby here, and I'm putting it in the property, and then I'm connecting to the server. I'm waiting on the finish event. If there's an error, it will show me. Then it's creating a lobby because everything in Tiny Lobby has to be in a lobby. So the main concepts are there's lobbies and peers, and if a peer is not in a lobby, it cannot call functions. So first we'll just create a lobby, and then when we click the button, we call lobby call with echo, and we put parameter, our first parameter. Now let's look for the second sample. It's a bit more complex. Here is lobby management. For this one, we don't use the scripted lobby, but we use the regular lobby. This one is just good for lobby management. In this case, we have on the left the host, on the right the peer. This could also be run on separate instances, but we're running them both in the same application. We will host the lobby, then we will see the lobby here. There is a small delay for performance reason on the lobbies listed. Then we copy the ID, and the peer puts the same ID, and they can join. And you can see here 2 out of 4. You can also update the lobby in real time. You can also put a password to the lobby, and if the peer leaves, they cannot join again without the right password. Also, you can ready up, and you can also set the lobby private so that it doesn't show anymore in search. How this is done? For this, we have 2 lobby clients. One of them, they both connect to list, but they both have different scripts. One of them connects to the lobby and the server, and then creates a lobby on host button, and the other one joins when the button is clicked. Here. Also, the other one calls list lobbies, which registers this lobby to the lobbies listed signal, and it will get triggered. And here you will just get all the lobbies that are getting created. If you want to stop this, you can call stop list lobbies, and you won't receive these events anymore. The next one is the chat sample. Here we have 4 lobby clients, and all of them connect to the same server and with the same game ID. And when they write a message, the message comes back. For this, the lobby client has a custom method called sendMessage, and when this is sent, it triggers a peer message signal. And all you have to do is listen to this and take the message. Also, you're getting the peer that sent the message. In this case, we're also sending, after we connect, the peer user data, which is data that you can put anything in, such as the name. In this case, each of them have a different name. Player 1, player 2 to 4. The next one is the pong sample, which is a bit more complex, and it has tick-based functionality. Looking at this, it's just two players again. This time, for their code, we're connecting them and we're quick joining. The quick join either creates or joins a lobby. And then on input, we call the function move. We also have scripts that listen to different events or on process read data from the lobby. This way it's very easy to split functionality so that you don't have to have all your logic on the lobby. In this case, the ball moves, getting the ball position, and then it does a smooth lerp. On the server, in the Pong demo, everything is written in Lua, and we have also a config.ini to specify that we want tick rate of 100 milliseconds. There is also documentation for this you can access. It has everything you will ever use in the Lua scripting, such as all the callbacks. Similar to Godot, you have callbacks for events. So when the server initiates, when somebody creates a lobby, when a peer joins. And then there's also public functions, and those are functions that don't start with an underscore. In our case, when somebody creates a lobby, it needs to have two players, otherwise it will give an error. And when the lobby is created, we set the public data. This data is always replicated from client to client. If you look to remote tab, you can see that you have everything here. You have the peers, and you can look here for the peer data, for example. You can debug everything that happens in real time. There's also peer and calling peer ID. So you can get the lobby. This is a package. I won't go too in detail into this, but basically the magic happens in the lobby tick function that gets called every 100 milliseconds. And here I do collision and I update the ball based on if a paddle hits it or not. The points functionality is handled here. And I have another function I call called reset ball that just resets the ball, and then I also increment the score of every player that won. Going back, we also have one more, which is the full sample, where you can test all the functions. In this case, every peer is a set of buttons. This one, for example, I can connect it and it has an ID. And then I have all the functions that it can use. This is for the normal lobby. I'm going to connect two peers. I'm going to have the first one create one lobby. Of course, if it has the size 0, it cannot create it. And then I'm going to have the second one join that lobby. And then you can ready up. You can see here the events are getting triggered. You can even do complicated things here, such as disconnect, and then take your reconnection token and reconnect with the same reconnection token. In this case, you will still be in the same lobby and the same peer ID. You can also set on the lobby you're using, you can also set data, but only tags and public data, and private data if you're the host. For the scripted, you can only set the tags and none of the other. So let's look. So I'm going to try to set public data. Okay, I'm going to have another peer join this lobby, and I'm going to see that this data should be replicated. I need to connect to the server first. And then indeed I get this data. And then if I go to the scripted lobby, it's the same functionality, just I have less functions because previously the host could set the data. And on this one, the main difference is that the host doesn't have as much access anymore. It can still kick peers though. Okay, that's it. If you have more questions, you can join the Discord and ask their questions, and more than happy to help you. Bye.